Hi, welcome to Aviation and ATC Keep Adequating channel. We hope that you and your family are doing well and are safe and healthy. This video lecture is about the automatic dependent surveillance broadcast. We will cover following contents. What is ADSB? How ADSB works? ADSB types, ADSB technologies, comparison of surveillance technologies, ADSB accuracy, ADSB concerns, and ADSB supported applications. What is ADSB? ADSB avionics enables an aircraft to broadcast its position information derived from global navigation satellite system, its identity, velocity, and other information with a very high degree of accuracy and integrity. ADSB ground station receive the information transmitted by an ADSB equipped aircraft and distributes the received ADSB data to ATS surveillance systems. The ADSB data sent by the ground receivers are processed by ATS surveillance systems and presented to the air traffic controllers as exclusive ADSB information or as integrated surveillance information, thereby providing enhanced situational awareness to the air traffic controllers. What is ADS? The arrival of satellite technology in the late 1980s brought with it the possibility of another type of ATC surveillance equipment, principally for use in areas where radar coverages does not or cannot exist. Originally known as PAN's Future Air Navigation System, this has matured into the system known as ADS, Automatic Dependent Surveillance. It is automatic because it requires no pilot or controller input to function, other than turning the equipment on and logging into the system, and dependent because it requires operating airborne equipment like SSR. The ADS system is basically a data link system that transmits data from the aircraft's onboard navigation system about its position, altitude, and intentions to the ground system. Dedicated ADSB ground stations can receive the broadcast and relay the surveillance information to ATC for precise tracking of aircraft. Other proximate aircraft can also receive the broadcast. What is ADS-B? P stands for broadcast. In this system, the aircraft has a special transponder that squitters or broadcast similar information to that described above, but at a much higher rate of twice per second. This information can be received either by a ground station for ATC service or by another aircraft. This leads to the possibility of so-called cockpit display of traffic information, CDTI. What is ADS-C? The original ADS system is now known as ADS-C contract because reports from the aircraft are generated in accordance with a contract set up with the ground system. For example, the ground system may demand reports when the aircraft reaches top of line, at position report points or other navigational waypoints, or at specified time intervals. These reports basically replaces verbal reports from the pilot and facilitate the application of procedural separation. Please view our video lecture on ACARS, comparison between ADS broadcast and contract. In ADSB, message is symmetrically sent Content is not fixed, programmable. In ADSC, messages are sent in the context of a contract. Broadcast, no designated recipient. In contract, messages are sent to only one known recipient. ADSB is a real-time surveillance. ADSC is far from real-time surveillance. Round trip time 3 minutes or more. ADSB range approximately 200 nautical mile. In ADS contract, range is unlimited. Please refer Akar's video lecture on this. ADSB, it's a air to ground, air to air, and ground to ground surveillance. ADSC, it's only air to ground surveillance. ADSB supported applications. The ADSB data link supports a number of airborne and ground applications. First is Cockpit Display of Traffic Information, CDTI. It is a generic display that provides the flight crew with surveillance information about other aircraft, including their position, traffic information. For a CDTI may be obtained from one or multiple sources, including ADSB, TICAS, and TISB. Direct air-to-air transmission of ADSB message supports display of proximate aircraft on a CDTI. Airborne collision avoidance. ADSB is seen as a valuable technology to enhance ACAS operation. Please refer our ACAS video. Incorporation of ADSB can provide benefits such as decreasing the number of active interrogation required by ACAS, thus increasing effective range in high density airspace. Reducing unnecessary alarm rate by incorporating the ADSB state vector, aircraft intent and other information. Use of ACAS display as a CDTI, providing positive identification of traffic. Extending collision avoidance below 1000 feet above ground level and detecting runway incursions. In addition to traffic based on ADSB reports, a CDTI function might also display current weather conditions, terrain, airspace structures, obstructions, detailed airport maps, and other information relevant to the particular phase of flight. Other ADSB applications are conflict management, ATS conformance monitoring, improved search and rescue, enhanced flight following, light control and operation, airport ground vehicle and airport aircraft rescue and firefighting vehicle operational needs, altitude height keeping performance measurements, general aviation operations control. How ADSB works. An aircraft with ADSB capability determines its position using GPS. The modus transponder then broadcasts that position at rapid intervals. Along with identity, altitude and velocity information is also broadcast. Dedicated ADSB ground stations can receive the broadcast and relay the information to air traffic control for precise tracking of the aircraft. Other proximate aircraft can also receive the broadcast. ADSBs consist of three components: a transmitting subsystem, a transport protocol, and receiving subsystem. A transmitting subsystem that includes message generation and transmission function at the source, which is aircraft. Aircraft can also be equipped with CDTI, but this is not essential. The transport protocol can be VHF mode 2 or 4, 1090 extended splitter, or 978 MHz UAT. A receiving subsystem that includes message reception and report assembly functions at the receiving destination. It can be other aeroplane, vehicle or ground system. Components of ADS-B aircraft equipment. All new Boeing and Airbus aircraft are now routinely being fitted with ADS-B out capability. ADS-B can either be achieved by software upgrade to an existing modus transponder or be installed as a freestanding unit. In the former case, the flight crew interface is included in the transponder control box will usually be provided with a separate ADS-B on or off and will be configured so that selection of the ident button will activate both SSR and ADS-B. Occasionally, an ADS-B equipped aircraft with a system linked to the transponder control box will not have a separate on-off switch, and the ADS-B function will be on whenever the transponder is on. If ADS-B is installed as a freestanding unit, then it will have its own control box with ident button and on-off switch. This last option is not yet very common. ADS-B information transfer, call sign, state vector, three-dimensional position, height, altitude, airborne turn indication, navigation accuracy category, emergency or priority status to air traffic services, current intent, CDTI. Types of ADS-B. ADS-B out, broadcast to all. It's mandatory. ADS-B in, receives the other broadcast. This feature is CDTI. ADS-B out, an ADS-B transmitter that enables the identity, position, and altitude of an aircraft to be determined and displayed to an air traffic controller or other station. The signal is broadcast at approximately every half a second. ADS-B out is the transmission of ADS-B information out from an aircraft to other aircraft or to ground station. ADS-B out would be made mandatory in airspace where ADS-B based separation is to be applied. ADS-B in, the onboard reception of ADS-B out transmission to allow cockpit display of nearby aircraft to the pilot of an ADS-B equipped aircraft is called ADS-B in. It means aircraft is fitted with ADS-B transmitter as well as receiver. Second component of ADS-B is transport protocol. ADS-B is an air-to-air or air-to-ground data link technique based on global navigation satellite system, which is used for the aircraft operational surveillance. Data link, which broadcast important surveillance information such as aircraft status, position, velocity, is a major component of the ADS-B system. Currently, there are three kinds of data link applicable for ADS-B. Mode S 1090 MHz extended squitter, VHF digital link mode 4, universal access transceiver UAT. ICAO SAPs are approved and published in Annex 10 for 1090 extended squitter and VDL4. Components of ADS-B transport protocol. 1090 extended squitter is the extended existing mode as transponder supports a message type known as the extended squitter. Mode S or mode select, despite also being called a mode, is actually a radically improved system intended to replace ground-based air traffic radar facilities. It is a periodic message that provides position, velocity, heading, time, future, intent. To enable an aircraft to send an extended squitter message, the transponder is modified. An aircraft position and other status information is routed to the transponder. ATC ground stations and traffic collision avoidance system equipped aircraft already have the necessary 1090 MHz receivers to receive these signals and would only require enhancements to accept and process the additional extended squitter information. Universal Access Transceiver. The UAT system is specifically designed for ADSB operations. UAT has a lower cost and great uplink capacity than 1090 extended squitter. Although 978 MHz resides in the assigned portion of the aeronautical spectrum, in the United States, 978 is used for transmission of airborne ADSB reports and for broadcast of ground-based aeronautical information. UAT users have access to ground-based aeronautical data, including traffic information services and flight information services. That includes weather and NOTAMs. VDL Mode 4. The VDL Mode 4 system could utilize one or more of the existing aeronautical VHF frequencies as the radio frequencies physical layer for ADSB transmissions. It is best used for short message transmissions between a large number of users. VDL4 uses a protocol that allows it to be self-organizing, meaning no master ground station is required. In November 2001, this protocol was published by International Civil Aviation Organization (ICAO) as a global standard. In the flight deck, a generic display would be used to provide the crew with surveillance information about other aircraft and would include existing devices such as TCAS. 1090 extended squitter downlink format. To own the capability of VDL Mode 4 and UAT, new devices must be installed in the aircraft. However, majority of the commercial transport aircraft have been equipped with Mode S transponders, whose hardware support the transmissions of Mode S 1090 MHz extended squitter ADSB data. Only minor modifications such as updating the software and installing the interface components is needed to realize 1090 MHz extended squitter data link. Compared to VDL Mode 4 and UAT data links, less workload and lower cost are introduced. 1090 MHz extended squitter is based on mode as extended squitter function of the secondary die. Both the negotiation signal and response signals have 56 bits short message and 112 bits long message. Data block whose first 24 bits represents a cow address code and other bits are used to transmit the parameter of the aircraft. 1090 MHz extended squitter is a technology based on mode as long message. Broadcast service architecture. Traffic information services broadcast TSB. This free service broadcast relevant traffic position reports to appropriate equipped aircraft. TSB information is available to aircraft that broadcast valid ADSB out and utilize ADSB in on 978 MHz UAT, 1090 MHz ES or both. The aircraft must be within the coverage of ADSB ground station and an FA radar or multilateration system to receive the target information. While ADSB increases, TSB significantly enhances pilot situational awareness for additional safety benefits. With traffic displayed in cockpit, pilots and air traffic controllers are able to communicate with shared awareness of conflicting aircraft traffic. With TSB, a pilot will not only see ADSB air-to-air traffic but also the radar targets sent from ground ATC radar position, resulting in a more complete picture of traffic around the aircraft. Flight Information Service Broadcast FISB. FISB is a free service available to aircraft who can receive data over 978 MHz UAT. FISB automatically transmits a wide range of weather products with national and regional focus to all equipped aircraft. Having current weather and aeronautical information in the cockpit helps pilot plan more safe and efficient flight paths, as well as make strategic decisions during flight to avoid potentially hazardous developing weather. Cockpit display of traffic information. A cockpit display of traffic information is a generic display that provides the flight crew with surveillance information about other aircraft, including their position. Traffic information for a CDTI may be obtained from one or multiple sources, including ADSB, TICAS, and TISB. Direct air-to-air transmissions of ADSB messages supports display of proximity aircraft on a CDTI. In addition to traffic based on ADSB reports, a CDTI function might also display current weather conditions, terrain, airspace structure, obstructions, detailed airport maps, and other information relevant to the particular phase of flight. ADSB surveillance quality indicators. ADSB has the advantage of low cost, small accuracy error, and strong surveillance capability. It can be applied in non-radar airspace. The air traffic service of the high density flight area and airport surface surveillance service. Therefore, it has been playing a more and more important role in future surveillance system of civil aviation. The airworthiness standard, which are to be complied with during the designing the ADSB and studies the airworthiness requirement for the position data quality of ADSB system. To understand accuracy and integrity of ADSB reported position, we have to understand HPL, horizontal protection limit, HFOM, horizontal figure of merit, and NUC, navigation uncertainty category, NIC, navigation integrity category, NAC, navigation accuracy category. We will discuss all of these terms. Before that, we must remember that ADSB message also contains the quality indicator of the reported position. Remember, no ground verification of the accuracy of information which is provided by the aircraft. NIC stands for Navigation Integrity Category. NIC defines radius of containment RC. All targets report should lie inside radius of containment. The NIC value is important in ensuring that the safety of the system by limiting the probability of false targets being established. Navigation Accuracy Category NAC. NAC, a radius around the aircraft inside which position reports will lie within a 95% probability. So NAC is smaller radius and NIC is the outer one. So neck will give you 95% of the probability where the aircraft will lie, whereas neck will give the radius of containment beyond which false target will be there and it will not incorporate into the system. Source integrity level SIL. The SIL defines the probability that the RC will be exceeded. If SIL equals 0, integrity limit is not known. Therefore, NIC is not meaningful. If SIL is equals to 1, it means less than once per 1000 flight hours. If SIL value equals to less than once per 100,000 flight hours. If SIL is 3, the probability that the RC will be exceeded less than once per 100,000 flights are. In order to give allowance to use the airborne position information in surveillance and radar-like separation service, the parameter horizontal position quality indicator would be provided together with the position by ADSB airborne system. The parameter which expresses the quality and creditability is based on the integrity and accuracy of the horizontal position information which is transmitted by ADSB. As for a GPS system, the integrity is measured by horizontal protection level. Left side, you can see integrity HPL, it's horizontal protection level, and the accuracy, which is right side, HFOM. So accuracy is measured by horizontal figure of merit. The parameter horizontal position quality indicator, which is integrity and accuracy, should be encoded in form of integral such as 1 to 9 in order to compress the message and improve the capability of communication. NUC, Navigation Uncertainty Category, is adopted to give a combined expression of accuracy and integrity requirement through a single parameter in RTCA DO260. It was used in the older system. However, RTCA DO260A and DO260B adopt navigation integrity category NIC, surveillance integrity level SIL, and navigation accuracy category NAC to encode integrity and accuracy separately. HFOM and HPL. HPL, horizontal protection limit, is the expression for the integrity of the horizontal position from GPS system. It is a figure which represents the radius of a circle which is centered on the GPS position solution and is guaranteed to contain the true position of the receiver to within the certain probability, which is usually 10 raised to the power minus 7. The horizontal protection limit is compared with the horizontal alarm limit to determine if RAM is available. Horizontal figure of merit represents the accuracy of the horizontal position information from GPS. It is a figure which represents the radius of a circle which is centered on GPS position solution and is guaranteed to contain the true position of the receiver to within the certain probability, which is usually 95%. HFMO is different as the position of GPS satellite measures changing. HPL and HFMOM have the similar definition but make differences. HPL determines the separation between two aircraft for safe flight, whereas HFOM determines the separation that pilots should be more cautious of the collision. Thus, aircraft will obtain its position from GPS. Thus, GPS integrity come into picture. RAIN, Receiver Autonomous integrity monitoring. It is a technology developed to assess the integrity of GPS signals in GPS receiver system. It is of special importance in safety critical GPS applications such as aviation or marine navigation. GPS does not include any integral information about the integrity of its signal. RAM is considered available if 24 GPS satellite or more are operative. Thus, GPS will calculate horizontal protection limit level, the integrity of the horizontal position from GPS system. This will broadcasted by aircraft transponder or ADSB transmitter. Now, the output of transmitter consists of position plus NUC or NIC. Once this is received by ground station or other ADSB in aircraft, which will determine position and figure of merit derived from the horizontal protection level. The information will be sent to ATC display system using asterisk 21 format. Asterisk is an all-purpose structured Eurocontrol surveillance information exchange. It is a standard for the exchange of ATS information. It is developed and maintained by the European ATS organization Eurocontrol. Asterisk not only stands for all-purpose structured Eurocontrol surveillance information but also represents a state-of-art surveillance data format which is nearly being adopted worldwide as a universal standard in this domain today. Asterisk category application. So if the 004 it is safety net messages, 011 advanced surface movement guidance control system, 021 ADSB target reports and so on. NUC consists of the integrity and accuracy of horizontal position in airborne ADSB system. In the air traffic control, ADSB data is accepted by the radar-like surveillance service of the ground station only when NUC is not less than 5. Because of its low cost, high precision, low error, and great surveillance capability, more and more attention is paid to ADSB system. We learned the fundamental of ADSB system, especially the ADSB system via 1090 MHz extended squitter. We studied the airworthiness requirements and industry standards which guide designing and manufacturing, focused on encoding rules and airworthiness requirements for the quality indicator of position data and provided the conversion relationship between different encoding rules. We hope you have liked it. Thank you for watching.